Today what we're going to be focusing on is Lab 9. Lab 9 focuses on F-testing. So F-testing is just looking at the different variances between two different groups. So for this lab, you're going to do questions 10, 12, 13, and 15. Today in this video, we're going to go over 10, 12, and 13. So the goal of this is we're comparing two different groups of people. So 12, 10, the output is right here. This is a question. For this lab, you're going to need to answer the question, provide calculations, and a detailed explanation. So for this first one, basically we're talking about children who wake up early for school. The claim is school that starts earlier, students aren't as focused as opposed to schools that start later. So the way we're testing this, we have there's a high school that changed their start time from 7:25 a.m. to 8:30 a.m. So we're looking at SAT scores for two groups of people. We have before the time change and then after the time change. And the goal of this is, can we infer that the data that SAT scores increased after the change in the school start time? So is it better or worse? And this is how we're going to calculate the, or how we're going to get the result. So our null hypothesis is our variance 1. So variance 1 is going to be before equals variance 2, which is after. So again, these two are equal to each other. That's our original claim. Alternative hypothesis is there's going to be greater variation in our before group, so the earlier start compared to the after group. So now we're going to use our F-test to basically calculate all of this. So for this, you're going to need to download the tool pack. We've talked about this in class multiple times. So make sure you download the tool pack for this lab. So you're going to go to Data, Data Analysis, and you're going to see F-test to sample for variance. You're going to hit OK. And then you have variable 1 range, which is going to be your before. And then your variable 2 range is going to be your after. You can click labels, and then our alpha is going to be 0.05. Remember, if I don't give you any indication of alpha, it's always assumed that it's going to be 0.05. So you're going to hit choose an output range and then hit OK. So here you're given a output. So out of this output, the most important values is your F-stat and then your F-critical one-tailed value. So we're comparing these two numbers. Because this is a greater, because our alternative hypothesis is greater than, we're looking at the right-hand side of this. So our critical value is 1.2. Now our F-stat is 1.14. And if we're looking at a greater than, it's not in the rejection region. So basically, we failed to reject the null. So we failed to reject the null because our F-stat, which is 1.14, is less than our F critical value. So I'll write it out here on the side. If your F-stat is less than your F critical, we're going to fail to reject our null hypothesis. And if our F-stat is greater than our F critical value, we reject our null. Okay, so when you compare these numbers, this is where you're going to need to know. So if we fail to reject our null, that means we're going to assume that our variances are equal. So if we assume that our variances are equal, we're going to run a t-test of 2 sample assuming equal variances. So basically this first step, so this is part of step 1, you basically want to calculate what kind of t-test you want to run. So first, you run a F-test. Second, you're going to run a t-test. So in this case, our F-stat is less than our F critical value. 1.14 is less than 1.2. So we fail to reject. Because of this, we are assuming the sample there's an equal variance between these two groups. Now from there, you're going to go back to your data analysis tool pack. And then you're going to scroll down and you're going to choose t-test 2 sample assuming equal variance. Again, this is based on your f-test that you just ran. So step 1 is an f-test, step 2 is a t-test, or the t-test of 2 samples. So now you're going to choose variable 1, which is our before, variable 2, which is our after, and for hypothesized mean difference, you're going to put 0. If our null hypothesis for our t-test is the SAT scores for the first group and the SAT scores of 2 groups are equal to each other, the difference is going to be 0. Now our alternative hypothesis is the SAT scores for individuals that wake up earlier are going to be much lower than individuals that wake up later, again, based on our claim. So our alpha is going to be 0.05, and then our output range, we can just choose any box, and you're going to hit OK. After that, you should get this output. Now the most important part here, so we're looking at less than, so we're going to compare, we can either compare our p-values or we can compare our t-stats. So here the most important values is this, and this. So you can use a combination of these 3. So if we were to compare our p-values, so our p-value in this case is 0.005, and our alpha, again, we've talked about alpha. If I don't tell you what it is, alpha is going to be 0.05. Now, because of this, for our case specifically, we're going to look at a one-tailed test, and we're going to look at the p-value. So our p-value is 0.0057, and our p-value is 0.05. So we've talked about the rejection and if we fail to reject based on this. So if our p-value is greater than alpha, we fail to reject the null. If our p-value is less than alpha, we're going to reject our null. So in this case, you're going to compare 0.005 to 0.05, and then you make your distinction. And from there, after you make your after you hypothesize what's going to happen, you're going to answer in terms of the question. So just make sure you answer in terms of the question. These are all the calculations. You should be able to figure out what this means and why this is important. So we're going to switch to 12.12. Again, very same setup. Here, we're assuming researchers at the University of Ohio surveyed 219 students and found that 148 had Facebook accounts. All students were asked their current GPA as well. Does the data allow us to infer that Facebook users have a lower GPA? So again, our null hypothesis, we're still going to do an f-test first, then we're going to do our t-test. So we do the f-test first to know what kind of t-test we need to conduct. So just before we do all that, I'm just going to copy and paste these. Okay, so the first thing we're going to do is calculate our f-test. We have our null, we have our alternative. Again, the variance with individuals with a Facebook is going to be much higher than individuals without a Facebook. That's our claim here. So we're going to go back to our data analysis toolpack, and you're going to scroll to f-test to sample for variances. Now our variable range, variable 1 is going to be individuals with a Facebook. Variable 2 is individuals without a Facebook. Our alpha is 0.05, and our output range, just select any box, and you'll be given this output. Now again, we're comparing our f-stat to our critical value. So if our f-stat, in this case, our f-stat is greater than our critical value. So if f-stat is greater than our critical value, we're going to reject the null. So we reject this null hypothesis that the variances are equal, And from there, we're going to conclude that they have unequal variances. Now from there, after you made that distinction, you automatically know that you're going to run a t-test to sample assuming unequal variances. So basically this first step is just to show you what kind of test you're going to carry out. Okay, so here we have our null and alternative, our GPA with the Facebook and GPA without the Facebook. We're going to assume a GPA with the Facebook is going to be lower than GPA without a Facebook. So again, go to your data analysis toolpack. You're going to choose t-test to sample assuming unequal variances. Hit OK. Variable 1 is going to be individuals with the Facebook. Variable 2 is individuals without a Facebook. Hypothesized mean difference is going to be 0. We do have labels. And we're going to choose our output range. Just put it right here. And then you're just going to hit OK. So now the numbers that you care about are right here. Okay, so from here, you can compare your p-values or you can compare your test stat. So our p-value in this case is extremely small. We're going to compare this to our alpha. Again, make a distinction. And from there, you can tell, do individuals that have Facebooks have a lower GPA or do individuals without a Facebook have a higher GPA? Again, it's going to be based off this. I do not want to see you comparing means. That's not the point of this exercise. It's the point to use hypothesis testing. So again, the very exact same steps. You're in charge of the explanation. These are the numbers. You should be able to calculate this. Now our last one. Here we're looking at a restaurant. So they're carrying out a new strategy to attract more customers. Now there's before the change that they made and then during the change, what happened to their sales. So we're looking at gross sales before and during. So our null is variances are the same, and the alternative, the variance for before is greater than the variance after. So again, first step, let me just copy and paste this stuff just so we have it. Okay, so first step is going to be go to your data analysis toolpack, ftest to sample for variances, hit OK. Our variable 1 range is going to be before. The variable 2 range is the during. Our labels, alpha 0.05, output range, hit OK. Now what we're going to be comparing is 1.16 to 2.357. Now again, it's this rule right up here. So in this case, our f-stat, so 1.16, is less than our critical value. So we're going to assume if we fail to reject the null hypothesis, we're assuming that the variances are equal. So now we run a t-test assuming equal variances. So our null and alternative for this, sales before equals sales after, and then alternative is sales before or less than sales after. So again, our goal is to show that this strategy is increasing our overall sales. So we're going to conduct a t-test of to sample assuming equal variances. You go to data analysis. You go to t-test assuming equal variances. Hit OK. So you're going to choose before as variable 1. Variable 2 is during. Hypothesized mean difference is 0. Alpha is 0.05. And your output range, you're just going to choose a box wherever you feel. And you're going to hit OK. Now from here, the most important boxes are these three. Now you're going to compare this value, our p-value, to our alpha. So our alpha and our p-value we have, you're going to make a justified claim and explaining what happened. Can the restaurant owner conclude that the advertising campaign is successful? So again, Are we going to fail to reject? Or are we going to reject our new null? So the first step, conduct the f-test for variances, and from there you're going to see if we use a t-test of unequal variances or a t-test of equal variances, and each have their own null and alternative. So you should be able to apply the same steps, same methodology to 1215, and you should be good for Lab 9. If you guys have any questions, drop a comment, email me. We can set up a one-on-one Zoom session, whatever is easier for you. We can do that. Other than that, I hope you guys have a good day, and I'll see you guys next time. Thank you.